A silent transformation is underway, far from the noise of daily headlines. It is happening in the humming server racks of vast data centers, and across the serene, spinning blades of wind turbines dotting the landscape. Digital intelligence, physical power. These two worlds are converging. This convergence is not merely an incremental improvement. It represents a fundamental rewiring of the global energy system. The core question is not whether AI will change energy and commodities, but how profoundly it will reshape how we generate, distribute, and consume power. The story of energy has always been a story of technological leaps. Steam, coal, combustion, oil, silicon, digital. To comprehend the scale of change, we must understand the foundational pillars of our modern energy world. These are the bones of the system, the structures upon which everything else is built. The first and most critical is the power grid. Imagine it as the planet's circulatory system, a vast, interconnected network moving electricity from generation to every home, factory, and office. It operates under an immutable law. Supply must match demand, instantly. Any imbalance risks blackout, demanding constant vigilance. Fuel markets, coal, gas, and oil remain a cornerstone of global stability and a primary source of emissions. The transition raises the stakes for metals, copper, lithium, cobalt, and rare earths. And the newest pillar, the data center, the factory of intelligence. It consumes massive energy and generates solutions to optimize the system. Artificial intelligence is a practical tool already delivering results. Its most visible impact, managing grid stability. Machine learning can forecast wind output more than a day ahead, unlocking value from renewables. Systems monitor weather, demand patterns, and generator status continuously. They balance fluctuating inputs with precision. From nations to neighborhoods, AI sharpens demand forecasting. In buildings, AI trims waste, adjusting lighting, heating, and cooling in real time. Predictive maintenance uses sensor data, vibration, temperature, acoustics, to catch faults early. Proactive repairs boost safety, reliability, and asset life. AI accelerates discovery, better batteries, more efficient solar cells, cheaper catalysts. It compresses R&D timelines, fast-tracking a cleaner future. AI binds the abstract world of data to the physical world of commodities. It reshapes how we price, trade, and manage oil, gas, coal, metals, and electricity itself. Algorithms process satellite images, vessel movements, and geopolitical news faster than any team. They fold signals into prices in milliseconds. Markets become more efficient. Arbitrage windows narrow. For power, forecasts and demand models enable dynamic pricing that reflects real conditions. AI optimizes physical flows, planning routes by weather, port traffic, and regional prices. It guides exploration, cutting risk and reducing footprint. Tracking carbon in real time lets electrons be priced by provenance. Markets align profit with decarbonization, the destination: efficient, transparent, sustainable markets. Promise is immense, but risks demand careful navigation. Supply chains are immediate pressure points. We depend on minerals and advanced chips from concentrated regions. A single disruption could stall progress worldwide. Use AI to map dependencies and diversify sources. Scale recycling and develop substitutes. Automation transforms grid operations, plant work, and commodity trading. A just transition requires reskilling at scale. AI's own energy demand is growing. Prioritize efficient models, site near clean power, and shift workloads to green peaks. Make transparent carbon accounting the standard. Success will depend less on the tech and more on the human systems around it. Rethink education and corporate training for lifelong learning. Invest in people, data literacy, cybersecurity, and AI operations. New jobs include AI oversight, data science, and robotics maintenance. Ensure no community is left behind. Embed ethics. Address bias as a societal, not just technical issue. Diverse teams and rigorous review improve fairness. Demand transparency. and allow audits. Governance must foster innovation while safeguarding the public. Define algorithmic trading rules to prevent manipulation. Finance should value efficiency, resilience, and sustainability. The future is not cold automation, but intricate, intelligent collaboration. Human ingenuity, amplified by machine intelligence. Turbines become connected nodes in a self-balancing network. Household data informs prices and grid stability in real time. Linking the smallest producer to the largest consumer, waste minimized at every turn. Built on data, shared securely and analyzed wisely. Predictive models guide lower impact material supply. Supply chains consume less fuel. Emissions precisely measured and priced. A technological, economic, and environmental victory. It requires deliberate action and courageous leadership. Invest in technology and people. Do more than keep the lights on. Illuminate a sustainable, prosperous future for everyone.